Spring 1945. The war in Europe is gasping its final breath, but in a quiet proving ground in Aberdeen, Maryland, a new kind of monster awakens. A team of American engineers stands in silence as a shape rises through the morning haze. Not a tank, not a vehicle, but a moving fortress of steel. 95 tons of armor groan as the T-28 super heavy tank lurches forward, each track link clanging like a hammer against an anvil. The ground trembles. Birds scatter from the trees. Its hull, nearly 12 feet wide, glints under the pale light. The barrel of its 105-millimeter gun stretches out like a spear, meant to pierce fortresses, not armor. Every bolt, every rivet, radiates the brute ambition of a nation that had learned war the hard way and was unwilling to face another entrenched line unprepared. The engineers exchange quiet glances. None of them know if this mechanical behemoth has arrived too late or too early. Because just as the T-28 begins its slow crawl, the war it was built for is already ending. By 1943, the tide of war had turned. The Allies were pushing back across Europe, but the lessons of earlier campaigns still haunted every strategist's mind. The Siegfried Line, Germany's formidable network of bunkers, pillboxes, and tank traps, stretching from the Netherlands to Switzerland, loomed ahead like a wall of concrete and steel. For American planners, the memory of the Maginot Line's failure and the bloodshed of Normandy's hedgerows fused into one grim realization. Breaking through hardened fortifications would demand more than courage. It would demand power, overwhelming mechanical power. The Sherman tanks that had carried the U.S. Army across France were reliable, adaptable, and fast. But against reinforced bunkers or heavy German armor, their 75-millimeter guns sometimes felt like hammers against stone. Reports from the European theater painted a clear picture. Tiger I and Panther tanks could outgun and outlast nearly anything the Allies fielded. While air power could destroy fortifications, relying on it alone was slow, imprecise, and costly. In the offices of the U.S. Army Ordnance Department, men like General Gladian M. Barnes, Chief of Research and Development, began to imagine something beyond conventional warfare. They envisioned a vehicle not for tank battles, but for siege warfare itself. A heavily armored machine capable of breaking through enemy lines, smashing bunkers, and surviving artillery fire that would vaporize a Sherman. By mid-1943, as Allied forces prepared for the Italian campaign and the eventual invasion of France, discussions emerged around creating what was then called the super heavy tank. The idea was not new. Every major power had flirted with oversized armor. The British had experimented with infantry tanks like the Churchill. The Soviets had built monsters like the KV-2. And deep inside Germany, engineers were sketching their own steel titans, the Maus and the 100. But the American proposal was different in purpose. It wasn't meant to duel other tanks across open fields. It was designed for deliberate assaults on fixed fortifications, the kind expected during the invasion of mainland Europe, and possibly Japan. Its mission: to lead armored columns through walls of concrete and flame, paving the way for infantry and standard tanks. In theory, the Allies already had the firepower. In practice, the war's terrain told another story. The hedgerows of Normandy, the ruins of Aachen, and the Siegfried Line's layered defenses turned battlefields into labyrinths of concrete and mud. Combat engineers with flamethrowers and satchel charges could breach bunkers, but at a terrible cost. Something had to shield them. Something invulnerable to machine guns and artillery splinters. Thus, in 1944, the Ordnance Department issued specifications for a tank capable of defeating any known fortification. Armor up to 12 inches thick,
a gun powerful enough to destroy reinforced concrete, a design simple enough to be manufactured, yet strong enough to withstand 88mm shells. The concept was radical, bordering on excessive. A vehicle weighing nearly 100 tons, slow but unstoppable. As Allied High Command reviewed plans for Operation Overlord and beyond, many saw this tank as a potential solution for Germany's final defense lines. The Siegfried Line, with its dragon's teeth and concrete nests, seemed impenetrable by standard armor. And if Japan's home islands needed to be invaded, its volcanic bunkers and cave systems would present similar nightmares. The project moved quietly, almost experimentally. Few believed it would reach production before the war's end, but it symbolized something more. America's growing confidence in engineering supremacy. The same industrial machine that built Liberty ships and bombers by the thousands could build a fortress on tracks. By late 1944, engineers at Pacific Car and Foundry in Seattle began turning blueprints into reality. Steel plates thicker than any tank before were cast and welded. Massive bogies and suspension systems were tested for the impossible weight. The Army named it the T-28 Super Heavy Tank, though its appearance made land battleship a more fitting term. The design was both ingenious and desperate, a creation born from the fear that Germany's defenses would devour another generation of soldiers. It represented one question: what if the next battlefield demanded something indestructible? And so, as American and British forces began their final push toward the Rhine, the T-28's blueprints lay on drafting tables thousands of miles away, an answer to a problem that was already shifting beneath their feet. For while the engineers forged a tank to crush bunkers, history was about to show them that speed, not steel, would win the race to Berlin.
In early 1945, the Pacific Core and Foundry Company in Seattle received a set of blueprints unlike anything they had seen before. The drawings detailed a vehicle that dwarfed every tank then in existence. The name on the cover sheet read simply, Heavy Tank T-28. The specifications were staggering. 95 tons in total weight, armor 12 inches thick at the front, a 105mm T5E1 gun, the same weapon used in U.S. tank destroyers, mounted in a fixed casemate rather than a rotating turret. No coaxial machine gun, no secondary armament. The T-28 was not a duelist, it was a siege weapon, a modern battering ram on treads. To any engineer, the challenge was monumental. The tank's sheer bulk meant it could not be transported by standard bridges, railways, or tank transporters. Even disassembled, its hull alone pushed logistical limits. But the Ordnance Department insisted the tank was vital. The Army needed something capable of assaulting the Siegfried Line and, if necessary, the concrete defenses surrounding Berlin. Pacific Car and Foundry had built locomotives, trucks, and armored hulls before. But this was different. The armor plating was so thick that welding demanded new methods and specialized torches. Components had to be machined with absolute precision. The final hull emerged from the plant like a silent leviathan, over 10 meters long and nearly 4 meters wide, too large for standard transportation, too heavy for most bridges. The T-28's suspension became its defining engineering feature. Designers adopted a unique 4-track configuration, 2 tracks on each side running parallel. For transport, the outer pair could be detached, reducing the width enough for rail movement, though transportable remained a generous term. Each track ran on 8 massive bogies with double road wheels, distributing the colossal weight to prevent sinking into soft ground. Even so, the tank's pressure per square inch was immense.
At its heart, the T-28 used a Ford GAF V8 gasoline engine, the same used in the M26 Pershing. But pushing 95 tons with a 500 horsepower engine meant sluggish movement. On paper, its maximum speed was 8 miles per hour. In practice, it struggled to reach half that across uneven terrain. The Ordnance Department acknowledged this flaw, but argued that speed was irrelevant. Its purpose was to move forward, steadily, inevitably, against enemy fortifications. Inside, the tank was austere. The crew of 4, commander, gunner, loader, and driver, sat in a cramped interior surrounded by steel walls thicker than a man's arm. Visibility was poor. Ventilation was worse. The 105mm gun could elevate and depress, but not traverse. To aim laterally, the entire vehicle had to turn. The T-28 would never be graceful, but it would be unstoppable. As production continued, war realities shifted faster than blueprints could keep up. The Allies had broken through the Siegfried Line by late 1944. By the time the first T-28 prototype rolled off the line, the Red Army was already at the gates of Berlin. The very fortifications that had inspired the tank's creation were being overrun, not by massive armor, but by maneuver warfare and air power. Still, the project pressed on. Officials reasoned the tank might find use in the Pacific, where Japanese fortifications on islands like Iwo Jima and Okinawa had bled U.S. forces dry. A machine that could withstand artillery and obliterate onkers might save lives in an invasion of the Japanese mainland. That justification bought the T-28 more time, though history would soon make it unnecessary. When Germany surrendered in May 1945, the tank was still incomplete, but the Ordnance Department refused to abandon it. They saw value in understanding the limits of armored engineering. What could be built? What could be moved? What could survive the unimaginable firepower of modern war? By the summer of 1945, the first prototype was ready for testing. Standing beside it, engineers and soldiers alike felt the same mix of awe and disbelief. The T-28 looked like something from another era, a machine built for a war that no longer existed. And yet, even as the headlines shouted "Victory in Europe," the Pacific still burned. The question lingered in every ordnance meeting. Could this be the key to breaking Japan's final line of defense? That question would shape the tank's final months and lead directly into the perspectives, ambitions, and rivalries that defined its short but remarkable existence.
The technological angle, a machine beyond its time. The T-28 was not simply another tank, it was a statement of what American industry could achieve under pressure. At 95 tons, it was the heaviest armored vehicle ever built by the United States. Its frontal armor, 12 inches thick, could deflect any German anti-tank weapon then in existence. Even the feared 88mm gun of the Tiger II would struggle to penetrate it. The T-28's 105mm T5E1 gun was designed to destroy bunkers, not tanks. Firing high explosive and armor-piercing shells, it could reduce a reinforced pillbox to rubble in a single hit. When test-fired at concrete slabs meant to simulate German defenses, the shells tore through solid material like it was wet clay. It was clear that if this tank had reached Europe in time for the Siegfried Line battles, it might have rewritten the playbook of armored assaults. But engineering brilliance came with consequences. The vehicle's immense weight demanded equally massive tracks. 2 pairs on each side, removable for transport but requiring hours of labor to reattach. Its mobility was limited to a crawl, roughly 6 miles per hour on flat terrain. In mud or soft ground, it could bog down easily. Its engine, though reliable, lacked the power to move such mass efficiently. Inside, the crew worked in claustrophobic silence. The driver's compartment was dimly lit, surrounded by levers and narrow viewing slits. The roar of the engine filled every space, and the smell of fuel hung heavy in the air. Maintenance required constant vigilance, every bearing, every bolt under immense strain. In essence, the T-28 was a fortress pretending to be a tank. Its armor and gun were unmatched, but its weight and speed made it unsuitable for modern maneuver warfare. Still, it represented a crucial moment in American engineering, a bold experiment that dared to test the outer limits of possibility. The Ordnance Department knew it was impractical, but they also knew it was valuable, as a laboratory on tracks teaching lessons about the extremes of armor, power, and mobility that would shape future designs for decades. The tactical angle, a weapon for sieges, not battles. The T-28 was never designed to fight other tanks. Its role was specific, to breach fortified lines that ordinary armor could not penetrate. In concept, it would move at the head of an armored column, drawing enemy fire while its 105mm cannon blasted through bunkers in anti-tank positions. Behind it, engineers and infantry would follow, exploiting the gaps it created. Its low speed was meant to be irrelevant in such a scenario. In siege operations, movement was measured in yards, not miles. The T-28's armor would make it nearly invulnerable as it advanced deliberately toward enemy positions. In a direct assault on the Siegfried Line, its gun could have flattened pillboxes that even heavy artillery struggled to destroy. But this tactical philosophy belonged to an earlier age. By 1945, warfare had evolved. Mobility, combined arms tactics, and air supremacy had replaced the slow grind of static assaults. The Allies had learned to outmaneuver fortifications rather than face them head-on. The T-28's theoretical battlefield had vanished before it ever existed. Even if deployed, it would have struggled with logistics, unable to cross standard bridges, too heavy for most roads, and nearly impossible to recover if damaged. Its turning radius was enormous, making it vulnerable in urban settings. Yet on paper, it filled a psychological role, the idea of an unstoppable machine capable of crushing the last bastions of resistance. For commanders haunted by memories of Monte Cassino or the Hurtgen Forest, the T-28 promised something reassuring, a tool to dominate the toughest defenses. In truth, it was a weapon designed for a kind of war the Allies no longer needed to fight. The leadership angle. Barnes and the birth of the supertank. Behind every experiment stood a visionary. For the T-28, that man was Brigadier General Gladian M. Barnes, the U.S. Army's Chief of Research and Engineering at the Ordnance Department. A mechanical engineer by training, Barnes had overseen development of the M4 Sherman and the M26 Pershing. But he believed future wars would demand even heavier armor and more powerful guns. He was fascinated by reports of German wonder weapons, the massive Maus tank, the V-2 rocket, and jet aircraft. He saw them as evidence that the next generation of warfare would be defined by technology as much as tactics. The T-28 was his answer, America's own demonstration of industrial might. Within the Army, not everyone agreed. Many officers favored lighter, faster tanks like the Pershing or upcoming prototypes that would evolve into the Patton series. But Barnes had influence, and his argument carried weight, literally. He insisted the T-28 could break enemy fortifications and save thousands of lives. The Ordnance Department authorized limited production, 4 prototypes at most. Only 2 would ever be completed. Barnes personally oversaw the trials, proud of what his engineers had accomplished. For him, the T-28 was not just a tank, but a symbol of American capability, proof that the U.S. could match or exceed any enemy's engineering feats. He wasn't wrong. In many ways, the T-28's existence stunned foreign observers, not least the Germans, who were themselves experimenting with even heavier designs. And it was there, across the collapsing front lines of Europe, that the true mirror image of the T-28 was being built, the German Maus. 4. The enemy's perspective, when steel met madness. Across the ruins of Germany, another group of engineers labored over blueprints that defied logic. In Stuttgart, under the direction of Ferdinand Porsche, the Panzerkampfwagen 8, Maus, the heaviest tank ever conceived, had begun to take form. Weighing nearly 188 tons, armed with a 128mm main gun, and encased in up to 240mm of armor, the Maus was the Nazi regime's desperate bid to outbuild the war itself. The Germans, by 1944, were facing annihilation. Yet in underground workshops and secret foundries, they pursued colossal machines, technological monuments to a dying empire. The Maus, like the T-28, was not a battlefield weapon. It was a psychological statement. It represented defiance in steel, a final act of technological hubris against the inevitable. When Allied intelligence later examined captured documents and incomplete prototypes, they were astonished. The Maus was nearly double the weight of the T-28, too heavy for any bridge, too slow for any maneuver, and nearly impossible to refuel or transport. And yet, on paper, it embodied the same obsession that had driven the T-28's creation: invulnerability. It is likely that if German engineers had ever learned of the American project, they would have been both impressed and perplexed. The two nations, locked in total war, had arrived at the same paradox from opposite directions. Both had built tanks that could not fight wars as they truly existed. In the collapsing factories of 1945, German engineers had begun another monster, the E-100, a proposed 140-ton tank meant to standardize super-heavy design. Only one incomplete chassis was ever built. Allied forces found it abandoned, a silent relic of a dream too heavy to move. To these German designers, the T-28 would have seemed familiar, a fortress on tracks, the ultimate siege weapon for a world that no longer needed fortresses. It was as if both sides, exhausted by years of destruction, had turned inward, seeking salvation through machines that symbolized strength rather than strategy. And in that mirrored ambition lay a profound irony. Both the Maus and the T-28 were triumphs of engineering and failures of purpose. 5. The human angle. Life inside the monster. For the few crews who operated the T-28 during its brief testing period, the experience was unforgettable. The tank's interior was cramped, stifling, and deafening. With the engine roaring at full throttle, the noise inside reached unbearable levels. Communication was nearly impossible without intercoms. The heat was suffocating. The thick armor turned the crew compartment into an oven. Yet there was awe, too. To sit inside the T-28 was to feel enclosed by invincibility. The massive steel walls gave a sense of security unmatched by any other vehicle of the time. When the 105mm gun fired, the concussion rattled everything: bolts, helmets, even lungs. It was raw power, elemental and terrifying. The driver's world was a narrow slit of vision, his movements deliberate and slow. Each turn of the control levers demanded strength and precision. The gunner and loader worked in unison, their every action choreographed in tight quarters. The commander's view periscope offered only glimpses of the outside world: fields, bunkers, and the long shadow of the tank's own barrel. Maintenance was relentless. After every test, the crews checked each suspension unit for cracks, each track link for wear. Grease, sweat, and oil mixed into a smell that clung to uniforms and skin. These men were not warriors in the traditional sense. They were engineers in helmets, custodians of an experiment too massive for war and too strange for peace. In interviews decades later, some who had witnessed the T-28's trials described it with reverence. It looked like something from another world. We knew it was too late for the war, but it was proof of what we could build if we had to. Inside its armor, one could sense both pride and futility. The pride of building something indestructible and the futility of knowing it had nowhere to go. 4. The moral and strategic angle. The weight of ambition. The T-28 was born not just from necessity, but from fear. Fear of stalemate, of fortifications, of the human cost of frontal assaults. It represented a desperate logic. If war demanded sacrifice, then build something that could absorb it instead of men. But behind every plate of armor lay a moral question. What does it mean when nations pour resources into machines meant to survive the very destruction they create? The T-28, like the German Maus or the Soviet KV-2, embodied a moment in history when human ingenuity collided with industrial excess. By 1945, it was clear that wars were no longer won by single machines. Air power, logistics, and mobility had replaced brute armor as the deciding factors. Yet nations continued to chase invincibility, a psychological shield against the horrors they had unleashed. The T-28 never fired a shot in anger. Its gun never shattered a bunker, and its armor never deflected a German shell. But its existence whispered a universal truth about human conflict, that even at the edge of victory, fear drives invention more than triumph does. In that sense, the T-28 was both a masterpiece and a monument to the ingenuity of its creators and to the illusions of safety that war makes us build. It stood as proof that the line between innovation and obsession is razor thin, and that even in victory, nations can be haunted by the weapons they almost needed. And as the T-28's massive treads turned slowly under the Maryland sun, it became clear that it was not just an experiment in steel, but a reflection of an entire world's ambition and exhaustion. The war was ending. Germany was in ruins. Japan stood on the brink. Yet in testing grounds across America, this steel colossus was just beginning to move. Its journey, brief, tragic, and unforgettable, was about to reach its defining moment.
Aberdeen Proving Ground, Maryland, late summer 1945. The war in Europe had ended. Hitler was dead. The Allies were preparing for Japan's surrender after the atomic bombings of Hiroshima and Nagasaki. Yet in one corner of the U.S. Army's proving grounds, a giant was finally ready to wake. The first T-28 Super Heavy Tank prototype stood silent in the morning light, its armor plates glinting like polished granite. Engineers circled it slowly, clipboards in hand, dwarfed by its sheer mass. A small group of Army officers watched from a raised platform. Among them, Brigadier General Gladian Barnes, the man whose conviction had brought this machine to life. The order was given, the engine roared. A deep metallic growl filled the proving ground as the T-28 began to move. The vibration shook the soil, sending ripples through puddles of oil and rainwater. Its twin sets of tracks clawed into the earth, leaving grooves half a meter deep. At a crawl of 6 miles per hour, it rolled forward like a moving wall, unstoppable, unhurried. To the untrained eye, it might have seemed ponderous. To those who understood its purpose, it was magnificent. The T-28 didn't need speed, it needed momentum. When it crossed a trench or crushed a row of obstacles, the earth itself seemed to yield before it. Observers compared it to a rolling fortress, and for a brief moment, the Army's vision of an invincible breakthrough machine seemed vindicated. Then came the firing trials. The T-28's 10.5-centimeter T5E1 cannon thundered across the proving range, its shell punching through reinforced concrete targets that simulated German bunkers. Dust clouds rose hundreds of feet into the air. In one test, a shell bored straight through 3 concrete walls before embedding itself in a hillside. The destructive power was undeniable. Yet, as the tests continued, so did the questions. How could a tank this large be transported across oceans? How could it maneuver on the narrow roads of Europe with the volcanic terrain of Japan? Bridges would collapse under its weight. Rail transport was theoretically possible if the outer tracks were removed, but the process required a crane, a team of mechanics, and several hours of work. Engineers noted another problem: the transmission. Designed for lighter vehicles, it strained under the T-28's immense mass. Every trial risked overheating. The tank's turning ability was limited, and the enormous casemate made it nearly impossible to traverse terrain quickly. Even slight inclines demanded careful handling. Still, Barnes remained optimistic. He believed the T-28 would prove invaluable for post-war studies or even future conflicts. He argued that if the United States ever faced heavily fortified enemies again, this vehicle would be a blueprint for how to defeat them. But in the weeks following Japan's surrender, enthusiasm began to fade. The strategic need that had given birth to the T-28 vanished overnight. No Siegfried Line remained to breach. No invasion of Japan loomed. The world was shifting from tanks to rockets, from massed ground assaults to atomic deterrence. By autumn, the T-28's tests continued more out of curiosity than necessity. Reports described it as impressive in power, limited in utility. The Army found itself studying a weapon without a battlefield. The T-28 was too slow for modern maneuvers, too heavy for existing infrastructure, and too costly to justify mass production. Yet, it refused to be forgotten. When placed alongside the M26 Pershing or the Sherman, the T-28 looked like something from another dimension, a vision of what warfare might have become if the war had dragged on. During one demonstration, a visiting delegation of officers stood in silence as the tank rumbled past. One reportedly muttered, "If the Germans had seen this in '44, they'd have thought the end had truly come." But that was the tragedy of the T-28. It had arrived too late to frighten anyone. Its armor was a monument to fear: fear of fortresses, fear of attrition, fear of sending soldiers into another blood-soaked wall of defenses. Now that fear had been replaced by another: atomic war. The age of atomic bombs made steel walls irrelevant. A single detonation could erase what tons of armor once promised to protect. Still, as the T-28 completed its final run across the proving ground that autumn, one could not deny its symbolism. It was a machine from another time, a relic of a war that had ended only months before, yet already belonged to history. Barnes watched as the tank came to rest, the engine's growl fading into silence. He had proven that America could build the world's most powerful tank. But in doing so, he had also proven something deeper: that the limits of technology could not outpace the limits of time. The T-28 was designed to crush Germany's walls. Instead, it stood as a monument to a different kind of wall, the one between human ambition and reality.
While the T-28 rumbled across the proving grounds of Maryland, more than 4,000 miles away, Allied soldiers were uncovering the physical evidence of Germany's own obsession with super-heavy armor. In the ruins of Kummersdorf and Böblingen, American and Soviet units discovered the skeletal remains of a tank unlike any they had ever seen: the Panzerkampfwagen 8 Maus. It lay half-buried, its hull scorched, its turret displaced by demolition charges. Only 2 prototypes had been completed before the war's end. One had been destroyed by its crew to avoid capture. The other was seized by advancing Soviet troops.
At nearly 188 tons, the Mouse made the T-28 look modest by comparison. Its armor, nearly 240 millimeters at the front, was impenetrable by any Allied gun. It carried a 28mm main cannon, supported by a coaxial 75mm gun. Yet despite its monstrous specifications, it had never seen combat. Its weight made it too slow, too fuel-hungry, and too fragile in logistics to operate effectively. The Soviets, inspecting the captured Mouse, were stunned. So were the Americans when intelligence reports filtered in. For both sides, it was a sobering revelation that even in collapse, Nazi Germany had continued to pursue technological extremity. The Mouse represented the end of a line of thinking that equated size with strength. An armored philosophy mirrored, unintentionally, in the T-28's creation. Both machines were built from the same fear, the fear of stalemate. Both were designed to break lines that no longer existed, and both arrived in a world that had already moved past them. When post-war analysts compared the T-28 and the Mouse, they found striking parallels. Each had emerged from different industrial cultures, but faced the same constraints: weight, mobility, and practicality. The Germans had attempted to build a war winner through sheer armor and firepower. The Americans had sought a bunker breaker that could end sieges before they began. In the end, neither machine had changed the course of history. By 1946, the T-28's testing continued intermittently. It was shipped from Aberdeen to Fort Knox for further evaluation. There, on open ground, its massive bulk rolled across test fields and shallow rivers, crushing obstacles with indifferent ease. Soldiers stood by, watching it crawl, cameras rolling to capture the moment. One report from the trials read, "The T-28 demonstrates exceptional protection and firepower. However, its extreme weight and lack of maneuverability severely restrict its tactical usefulness. The vehicle is of limited value beyond experimental purposes." It was a polite eulogy for an idea that no longer had a place. Meanwhile, in Europe, the Mouse was disassembled and sent to the Soviet Union for study. Engineers examined its systems, its gun, and its absurdly thick armor. Then, like the T-28, it was quietly shelved. A curiosity for future reference, not a template for new designs. The war's technological race had reached its natural conclusion. Both sides had built tanks too large to fight. Yet these failures were not meaningless. They revealed the hidden cost of total war, how fear of defeat drives innovation beyond reason. When commanders demanded invincibility, engineers delivered it, only to discover that indestructibility came at the price of utility. In the T-28's case, that truth became undeniable when the tank's transportation trials began. Moving it between proving grounds required dismantling its outer tracks and loading it onto specially reinforced flat cars. Even then, bridges along the route had to be checked and roads closed to all other traffic. Each relocation was a logistical operation in itself. The tank could cross trenches and crush obstacles with ease, but it could not cross a standard bridge. It could shatter bunkers, but it could not redeploy quickly enough to meet changing threats. It was a paradox, a weapon that could survive any battlefield except the one it lived in. By 1947, the T-28 was no longer a secret. Photos appeared in military journals, showing its immense size and squat profile. Foreign analysts, including those in Britain and the Soviet Union, took notice. Some admired its raw power, others dismissed it as an engineering dead end. For General Barnes, the project's end was bittersweet. His vision of an indestructible tank had been realized, but it was already obsolete.
The world's attention had shifted from armor thickness to atomic potential, from trench lines to missile ranges. Tanks would continue to evolve, but never again in the image of the T-28. When asked years later about the project, one ordnance engineer summed it up bluntly. "We built it because we thought we might need it. By the time we finished, the world had changed." And so the T-28, like the mouse, became a monument to that change, a silent colossus left behind by history's fastest-moving war. By the late 1940s, both prototypes sat quietly in American storage yards, surrounded by rows of smaller, more practical tanks. Grass began to grow around their tracks. Their armor no longer glinted under test range lights. They were too big to destroy, too unique to forget. But history wasn't finished with them yet. One of the T-28s would vanish, lost in the wilderness for decades, only to be rediscovered by accident. A ghost of the war that never came.
By 1947, the war was over. The world had changed, and the T-28 stood as a relic of an age already fading into history. The U.S. Army Ordnance Department, now focused on atomic readiness and Cold War containment, had little use for a 95-ton bunker buster. Yet protocol demanded that every weapon, no matter how improbable, be fully evaluated before being written off. At Fort Knox, Kentucky, the T-28 underwent its final series of trials. Engineers from the Armored Board observed each test with detached curiosity. The tank was a marvel of construction, its welds seamless, its armor unblemished, but its purpose was gone. When the test officer's signal came, the crew ignited the Ford GAF engine, and the machine stirred once again. On the proving ground, the T-28 crawled forward, flattening the test obstacles prepared for it: wooden barricades, earthen berms, concrete walls. It performed flawlessly, proving it could do what it had been designed for: destroy fortifications. But the observers' notebooks told a different story. The world now demanded mobility, not mass. In the age of jet aircraft and atomic weapons, warfare had entered a new dimension. The T-28's armor was thick enough to deflect artillery, but meaningless against an atomic blast. Strategists were thinking in continents, not trench lines. Mobility, rapid deployment, and nuclear survivability became the new doctrine. Reports from Fort Knox reflected this change in tone. One document reads, "Vehicle displays extraordinary protection and firepower. However, it cannot be supported tactically or logistically under modern conditions. Primary value is experimental." The verdict was clear. The T-28 was too heavy for the roads it would defend, too slow for the battles it would fight, and too outdated for the wars yet to come. Still, the Army was reluctant to scrap such a feat of engineering. Two prototypes had been built, T-28 No. 1 and T-28 No. 2, and both were kept for reference. Engineers wanted to study their suspension systems, their armor metallurgy, and the stress points that appeared during testing. The tank had failed as a weapon, but succeeded as a teacher. In those years, the T-28's quiet endurance began to symbolize something larger than its steel frame. To the men who had worked on it, it represented the last great leap of wartime engineering, the final attempt to solve a 20th-century problem with 19th-century logic. Then, as the 1950s dawned, the U.S. military changed direction entirely. The Pershing evolved into the M46 Patton. The M48 and M60 followed. Each generation was lighter, faster, and far more practical. The age of the super heavy tank had ended almost before it began. The T-28 was officially redesignated 105mm gun motor carriage T-95, a bureaucratic footnote marking its transition from potential battlefield weapon to test platform.
Trials continued at Aberdeen and Yuma Proving Grounds into the early 1950s, largely to study how extreme weight affected track wear and suspension life. Eventually, the tests ended. One prototype was sent back to Aberdeen for storage. The other, T-28 No. 2, was left at Yuma for additional evaluation. There, in the blistering Arizona sun, surrounded by miles of desert scrub, the massive vehicle was parked and largely forgotten. Years passed, records faded, personnel changed, the Cold War intensified, and the T-28's name disappeared from official schedules. When the Ordnance Corps reviewed its inventories in the 1960s, only one T-28 was accounted for, the unit at Aberdeen. The other had simply vanished. For historians, it became a curiosity, a 95-ton ghost. Some believed it had been scrapped quietly to reclaim steel. Others thought it might have been buried or used as a target. Its disappearance became a minor legend within ordnance circles, a symbol of how swiftly the post-war world had moved on. But the T-28 was not gone. It was waiting, silent and immovable, half buried in sand. 2 decades later, the Earth would give up its secret.
The story of the T-28 might have ended there, buried in paperwork and forgotten steel, if not for a strange discovery in the summer of 1974. A team from the U.S. Army conducting a land survey near Fort Belvoir, Virginia, came across something that didn't belong. At the edge of a wooded training area, beneath layers of soil and brush, they noticed the corner of a massive steel plate protruding from the ground. When bulldozers cleared the area, what emerged was astonishing. The missing T-28 prototype, its olive drab paint faded, its tracks half consumed by earth, but its hull intact. No one could fully explain how it had gotten there. Some records suggested that it had been sent to the area in the late 1940s for cross-country mobility trials and simply abandoned when the program ended. Others believed it had been moved there for classified testing and forgotten amid post-war downsizing. Whatever the reason, it had slept undisturbed for nearly 30 years. The rediscovery sent a quiet ripple through the military history community. Photos of the unearthed giant, streaked with rust, its 105mm gun still pointed forward, began circulating in engineering departments and archives. Many younger officers and soldiers had never even heard of the T-28. To them, it looked like something from a lost world. The Army quickly organized a recovery operation. Using multiple bulldozers and specialized flatbed trucks, crews hauled the immense vehicle out of the forest. Its condition astonished restorers. Though weathered, its structure remained sound. Even the suspension, though seized, showed minimal corrosion. After inspection, the decision was made to preserve it as a historic artifact. In 1975, the T-28 was transferred to the Patton Armor Museum at Fort Knox, now the General George Patton Museum of Leadership. There, for the first time, the public could stand before the machine and grasp its scale. Veterans who had served in World War II came to see it with mixed emotions. Some regarded it with pride, a symbol of American ingenuity and industrial power. Others saw it as a reminder of the excesses of war, a weapon built for a battle that never came. Children stared up at it, awestruck by its size. The tank's glacis plate rose higher than most men. Its double sets of tracks spread nearly 4 meters across, filling the museum yard like a metal fortress. To stand beside it was to understand why German engineers, upon learning of its existence after the war, had been both impressed and relieved. The T-28, like their own mouse, proved that even the greatest industrial powers could push technology too far. In subsequent years, restoration efforts stabilized the tank. Its hull was cleaned, its engine bay sealed, and its casement interior preserved as it had been in 1945, stark, functional, without comfort or ornament. For historians, it became a tangible bridge to the final months of the Second World War,
a symbol of what happens when human fear and ambition collide at full industrial scale. Meanwhile, its influence lingered subtly in American design philosophy. Though no tank would ever again approach its mass, lessons from the T-28's suspension, armor joining, and mobility trials informed later research. The U.S. military learned that extreme weight imposed extreme limits, that survivability could not come at the cost of flexibility. By the Cold War's height, the U.S. main battle tanks like the M60 Patton and later the M1 Abrams embodied that balance. They combined protection, firepower, and speed, the opposite of the T-28's single-minded design. Yet in each evolution, the echo of the T-28 remained. The recognition that even in the pursuit of invincibility, there are boundaries that must not be crossed. Today, the T-28 rests quietly at the National Armor and Cavalry Museum at Fort Benning, Georgia. Decades of sun and rain have weathered its armor to a dull gray green. Tourists and soldiers pass it daily, a silent sentinel of another age. The plaque beside it tells only part of the story, its specifications, its builders, its purpose, but the real story lies in what it represents: the ambition of a nation racing to end a war, and the limits of human engineering in the face of time itself. As the sun sets across the museum grounds, its shadow stretches long across the concrete, a monument to an era when engineers believed they could build invincibility out of steel. And in that shadow lies the quiet lesson the T-28 left behind, that even the strongest armor cannot protect against the passing of history. In the fading light of history, the T-28 stands not as a weapon, but as a mirror, a reflection of a moment when humanity believed that strength could be measured in inches of armor and tons of steel. When the T-28 rolled out of the Pacific Car and Foundry plant in 1945, it embodied the ultimate wartime logic, that protection equaled survival. Each plate welded to its frame was an answer to fear of German fortifications, of entrenched defenses, of soldiers dying in fields they could not cross. It was the physical manifestation of the promise that technology could save men from destruction. But history would prove that promise incomplete. Wars do not wait for perfection. They move faster than steel can cool. By the time the T-28 was ready, the battlefield it was built for no longer existed. The Siegfried Line had fallen, Berlin had burned, and the atomic age had dawned. The tank arrived not as a savior, but as an echo, a monument to the momentum of war itself. And yet, in its failure, it taught something profound. The T-28 revealed the point at which innovation turns inward, when the drive to build stronger machines collides with the limitations of reality. It showed that technology, no matter how formidable, must serve strategy, not surpass it. In a sense, the T-28 was the last of its kind, the final embodiment of the superweapon dream that had haunted both Allied and Axis engineers. After it came the era of balance, of design shaped not by fear of the enemy, but by understanding of the environment, the soldier, and the mission. Today, as it rests beneath open skies at Fort Benning, its silence carries more weight than its gun could ever. Visitors stand before it and feel a mixture of awe and melancholy, the awe of what human hands can build, and the melancholy of knowing why they built it. The T-28 never fired a shot in anger, but it still speaks, to the engineers that designed it, to the soldiers that might have crewed it, and to every generation that dreams of building something indestructible. Its message is simple, carved into history without words. There is no armor thick enough to stop the march of time.